We have already talked about a lot of discrete random variables. Now we will give a proper definition of it. So x is a discrete random variable if it takes at most a countable set of values. So it takes some discrete set of values x1, x2, x3 and so on in real numbers. For example, you have a simple coin toss. The sample space is head or tail. So you can define a random variable x1 as x1 of head is 1 and x1 of tail is 5. So we have discussed this example before. You can talk about another example of two coin toss. You have head, 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 tail, tail, head or tail, tail. And then you can define a random variable which counts the number of heads. You have y of head, head is 2, y of head, tail is just 1 head, y of tail, head is just 1 head, y of tail, tail is 0 head. So associated to each value xi here in the set of outcomes, we assign some positive probability. And for all values v which do not belong to this set, we assign a probability of 0. So the probability associated with the random variables is called the probability mass function. So this is the probability mass function, p of x equals to xi. So you add up all the probabilities, they add up to 1. So you can see this in this example here. So here random variable takes value 1 or 5. So you add those up. You say probability of x equals to 1 plus probability of x equals to 5. So 1 is associated with head, so you take probability of head here, it is half, plus probability of x equals to 5. This is associated with tail, so you add half here, this becomes 1. Similarly, we can talk about the probability mass function here. So you have probability of y is equal to 2 plus probability of y is equal to 1 plus probability of y is equal to 0. This 2 is associated with head, head, so you get 1 by 4. Probability of y equals to 1 here is probability of head, tail plus probability of tail, head. So these are two events here. So you have plus 2 by 4 plus probability of y equals to 0. This y equals to 0 is associated with tail, tail. So probability of tail, tail is 1 by 4. You add them up, you get 1. So this is what it is. So this is again, so this is basically equal to probability of capital X less than or equal to small x. So you basically pick out all the xi's which are less than or equal to this small x, which is a real number, and add them up. So this will be clear in an example. So say this random variable x takes on 3 values 1, 2 and 3. The probabilities are probability of x takes on 1 is half, probability x takes on value 2 is 5 by 16, probability x takes on value 3 is 3 by 16. So we have 3 values to worry about, 1, 2 and 3. So this is 1, 2 and 3. So before 1 nothing happens, so x is less than 1, so less than 1 means there is a hole here. So less than 1 it just takes value 0. At 1 it takes value half, so there is a jump half. So to 0 you add half, so that is what the summation here means. So to 0 we have added this first half. So between 1 and 2 it takes value half. So again 2 is not in the interval because there's a less than sign. So at 2 you add 5 by 16. So you add 5 by 16 to half. So notice that half you can write as 8 by 16. 8 by 16 plus 5 by 16 will give you 13 by 16. So you add half to it. So say you get 13 by 16 right here. So say you have 13 by 16 here. So again you will have a hole right here. And to 13 by 16 at 3, it is from 2 to 3 nothing changes, because after 2 the only value which the random variable takes is 3. So between 2 and 3 nothing changes. So at 3 there is another jump which is 3 by 16. So you add 3 by 16 right here and you get 1. So you continue getting 1. So as you go towards plus infinity, you remain 1. As you go towards minus infinity, you remain at 0. So again, for this random variable, you can see as this small x goes to 0 or small x goes to minus infinity, this goes to 0. And as x goes to plus infinity, this goes to 1. And you can see how we add the values up. So we are adding the values of the random variables, and that is what the summation sign means. So when you're talking about less than or equal to 2, then you're talking about 5 by 16 and half, and that is 13 by 16, and so on. So this is an important example, and the probability mass function is precisely this function. So this is the probability mass function. It has three values: half, 5 by 16 and 3 by 16, and you add them up, again you get 1. So half plus 5 by 16 plus 3 by 16, you add it up, you get 1. So this is the probability mass function associated with the random variable capital X.